Open the settings screen in this app before today's commit, and every row is a lie. Language says system default. Theme says auto. Default country says EU27 SY 2020. Those are string literals baked into the composable, not values read from anywhere. Tap clear cache and nothing happens. There is no wiring behind that row at all. Pick dark theme and the app stays exactly as light or dark as the OS decided when it launched, because Eurostat theme never looked at a preference in the first place. In this commit 4F68BE6, we replace all of that with a real SQLDelight-backed preference store, a key value table, driver notified flows, a rebuilt settings screen wired to real intents, and Eurostat theme actually reading the saved theme on every recomposition. Let's start with the contract in Core Common. Core Common gets a new interface app preferences in the prefs package. It exposes three read properties as Kotlin flows: theme preference of type theme preference, language as a string and default country as a string, and default country as a string, plus three suspend setters: set theme preference, set language, and set default country. Notice what is missing: no SQLDelight import, no database class anywhere in Core Common. This module only knows about flow and coroutines. The production implementation is SQLDelight-backed and lives entirely in core database. So tests elsewhere in the app can implement this interface with a trivial in-memory fake and never touch a real database. The companion object pins the defaults: default ascooge and squetty, the EU27 aggregate squetty7 squetty20, the EU27 aggregate reads documented here never fail. An unset key is defined to emit these defaults, so callers never have to handle a null or a missing preference error state. Theme preference is a plain enum with three entries: system, light, dark, but it carries one extra property: storage value, a getter that maps each entry to its own lowercase string. System, light, dark, through an explicit when expression rather than relying on Kotlin's built-in name property. That is a deliberate choice. If a future refactor renames the DAC constant to something else, every row already written to SQLite by SQLDelight app preferences still passes correctly, because storage value for that entry never changed. The companion objects from storage function is the inverse. It searches entries for a matching storage value and falls back to system if the value is null or does not match anything at all. Corrupt or hand-edited data can never crash the theme root. This small enum is the only place theme values get translated between Kotlin and plain text, and it is covered directly by one of the new database tests. The actual storage lives in a new SQLDelight file, preferences SQ, inside core database. It defines one table, preference entity, with two columns, preference entity, with two columns, preferry key as a non-null text primary key, and pref underscore value as non-null text. Two queries follow. Select by key returns the preference the base shoe value for a given key. Upsert is an insert or replace into statement. So the very same call handles both the first write and every subsequent update, no separate insert versus update branching in Kotlin. Because reads fall back to code level defaults when a key is missing, there is no seed migration needed for brand new installs. The table simply starts empty and gains rows only as the user actually changes theme, language, or default country on the settings screen. Three keys total: theme, language, default underscore country. Adding a table to a ESDOL-CAK file is only half the story for anyone who already has the app installed. The comment inside the new migrations/two-way seqway file spells out why Android SQ8 driver and native SQ8 driver only run schema.create in full on a brand new database file, and they only run migrations when the existing user Daska version is less than schema-migrations. An install that is already sitting at schema version 2 will never see preference entity appear unless a migration step creates it explicitly. So 2xqm repeats the exact same create table preference entity statement that lives in preferences.sql, same primary key, and the comment warns future contributors to keep both definitions in sync by hand. Schema version bumps from 2 to 3. The test suite added in this commit runs the full v1 to v3 chain end-to-end and asserts preference entity actually exists afterward, not just that the migration function returns without throwing. SQLDelight-backed preferences implements app preferences over an app database and a dispatcher provider. Each read property is built from a private raw value helper db.preferences queries.select by key of the key, then asflow, then map to 1 or null on dispatchers.io. Asflow is the SQLDelight coroutines extension that reruns the underlying query automatically whenever a write through the same app database instance touches the table it depends on. There is no polling interval anywhere in this code. Team preference maps that raw nullable string through team preference.fromStorage. Language and default country fall back to app preferences.default, iv language, and default country when the raw value is null. Every setter funnels through a private write function that wraps db.preferences queries.cert in with context of dispatchers.io. Because the settings screen and the theme root both collect from this exact same driver notified flow, changing the theme in one place is visible in the other within the same frame, with zero manual notification code. Cache finally does something. SQLDelight Cache Maintenance implements the new cache maintenance interface from Koin, and its one function, clear all caches, wraps db.transaction around 8 clear all calls, one for each of population cache queries, economy cache queries, environment cache queries, environment cache queries, trade cache queries, Sonos cache queries, social cache queries, science cache queries, and multi-dim cache queries, the JSON blob cache. Every one of those clear all queries, a plain delete from the corresponding cache entity table, was added to the 7 per feature .xq files in this same commit. Multi-dim cache queries already had one. Wrapping all 8 deletes in a single db.transaction means a failure pathway through never leaves the cache half-emptied. It is all or nothing. Preference entity is conspicuously absent from that list. Preferences are user data, not cache, and the whole point of this class is to never touch them. A dedicated test seeds a preference row, clears the cache, and asserts that row survived untouched. Here is the payoff in Compose app's MyEuroStatApp. It resolves app preferences lazily through Koin platform.getKoin, wrapped in, remember, lazily, because every platform entry point starts Koin before this composable runs. Theme preference is collected as state with collect_as_state, seeded with an initial value of theme preference.as istem, so the very first frame has something sane before the flow's first real emission arrives. A when expression turns that preference into a plain boolean. System defers to each system in dark theme. Light is always false, dark is always true. That boolean is passed straight into Eurostat theme as its dark theme parameter, which used to be called with no arguments at all, always following the OS. Because collector state recomposes on every emission from the SQLDelight-backed preferences flow, picking a new theme on the settings screen rethemes the entire running app immediately, no restart required. Default settings component now takes up references, cache maintenance, and the dispatcher provider in its constructor, alongside the existing component context. Its init block launches a coroutine that calls combine over 5 flows at once: preferences.theme preference, preferences.language, preferences.loophole country, and 2 local non-persisted mutable state flows is clearing cache and cache cleared that track the in-flight state of a cache wipe. The combined lambda builds a single settings UI state content and collects it straight into the component's exposed state flow. On intent dispatches set theme, set language, and set default country, each as a one-line scope, launch calling the matching app preferences setter. Clear cache routes to a private clear cache function that checks is clearing cache.value first and returns immediately if a wipe is already running. That is the reentry guard mentioned in the commit message. Otherwise, it flips is clearing cache to true, calls cache maintenance.clearCache wrapped in run catching, and reports success or failure through cache cleared through. So app preferences and theme preference in core command define a database agnostic contract. Preference entity, schema version 3, and the 2.q migration give it real storage that upgrades existing installs safely. SQLDelight app preferences exposes driver notified flows, so every observer stays in sync without polling. SQLDelight cache maintenance clears all 8 cache tables in one transaction, while leaving preferences alone. Default settings component combines those flows into a single UI state with a guarded clear cache action, and MyEuroStatApp finally reads the persisted theme instead of ignoring it. This commit ships 18 new tests across the settings component, the preferences store, cache maintenance, and the full schema migration chain. If you want to land on exactly this step in your own checkout of the repository, run git checkout for F68BE6. Full repo link is in the description. Subscribe for the next KMP Build episode.